どうも皆さん、英語で数学、瀬戸です。今回は指数関数についてレクチャーしたいと思います。Let's start with the definition of the number e. We consider this limit, the limit as x goes to 0, of 1 plus x to the 1 over x, as the number e. So it can be shown that this limit exists. You can plug in some numbers and you'll get the approximation that e is the number that's around 2.718. So, what's so special about this number? Well, for h close to 0, we can say that e is roughly equal to 1 plus h to the 1 over h, which means that e to the h is roughly 1 plus h, and so e to the h minus 1 divided by h is approximately 1. And now let's consider the function f of x equals e to the x. This is the exponential function. So when you plug in different values of x, you exponentiate e to different values here. And now let's take the derivative. Using the definition of the derivative, we want to evaluate this expression, the limit as h goes to 0, of e to the x plus h minus e to the x divided by h. Now, recall that addition in the exponent is multiplication in the base, so we can factor out an e to the x. And we get this expression. The number e was defined to be the number such that basically this limit goes to 1 as h goes to 0, and so the derivative of e to the x is actually just e to the x. And e is the special number so that this happens, that the derivative of the exponential function to this base is e to the x. Next, we define the natural log function as the inverse function to the exponential function, meaning y equals natural log of x if and only if e to the y equals x. And so we have e to the natural log of x is x, and natural log of e to the x is also x. They are inverse functions. The natural log function has the following properties: that the natural log of the product is equal to natural log of x plus natural log of y. The natural log of the quotient is log x minus log y, and log x to the r is r times natural log of x. As an application, we can write any number, for instance 2 to the x, as base e, so 2 to the x can be rewritten as e to the x times natural log of 2, because we can move the x into the exponent of natural log, and then e and natural log are inverse functions, so this is just 2 to the x. Now let's investigate the derivative of natural log. If y equals natural log of x, then how can we find the derivative? We can of course write out the definition of the derivative, but there's actually a quicker way to do this using implicit differentiation. Now, y equals natural log of x is equivalent to e to the y equals x. And now we differentiate both sides with respect to x. We have to use chain rule. The derivative of the exponential function with base e is itself. So we get e to the y again, but we have to multiply by the derivative of the inside function by chain rule. So we multiply by y prime, and then the derivative of x is 1. Now we isolate y prime. Y prime is 1 over e to the y. E to the y is x, so the derivative of natural log of x is 1 over x. As an application, we can do what's called log differentiation to a rational function. We can of course find y prime using quotient rule, but we can also use natural log to avoid using quotient rule. So how do we do that? We take natural log of both sides, but using the properties of log, we can split this up. And now we take the derivative of both sides using implicit differentiation. The derivative of natural log is 1 over the inside function multiplied by the derivative of the inside, which is y prime. The derivative of natural log of all of this, we use chain rule, so it will be 1 over the inside function times the derivative of the inside function. And we'll do it once more. Derivative of natural log of x squared plus 1 is 1 over x squared plus 1 multiplied by the derivative of the inside function. And now we multiply by y to both sides. And so the derivative will be this expression. If we want to take the derivative of a different base, for instance, a derivative of 5 to the x, then we rewrite this as e to the x times natural log of 5. The derivative of the exponential function is itself multiplied by the derivative of the inside function, which in this case is x times natural log of 5. Natural log of 5 is just a number, so the derivative of x times a number is just that number. So we multiply it by the derivative of x times natural log of 5, which is natural log of 5, but e to the x times natural log of 5 is 5 to the x. And so the derivative of 5 to the x is 5 to the x times natural log of 5.